So I'm going to showing you how to create like a, so like as I said in Houdini 18, Pyro Simulation is much easier. So you don't need to create a a sub-level things and then go to a top-level network, simulate that, blah blah. Everything has been streamlined. So let's say the question is, how can I create a sandstorm? So let's call this sandstorm. So I get inside. So let's say this sandstorm is getting emitted from like a source. I don't know, maybe a sphere. Tap sphere. Put the sphere there. That's a NERP sphere. I press. So you know how it works in Houdini. So I like to see all my node network pretty nice and neat. So that's why I click here, close it. So there's all these ways of working in Houdini. Just make it comfortable. So like I close that one, and whenever I need parameters, P stands for parameters, I press P, easy. So so I click on that little triangle on top, push it up, and press P to bring my attributes. Okay, or if you're comfortable, like it's just preference. If you're comfortable, you can keep it open here, and just like every time, just it's just a matter of preferences. This is gonna be a polygon, and I just press, and I can hold the, I just want to add a transform node because I just want to make it larger. Oh, by the way, very important thing about every simulation is units. So whatever you're looking there, you have to just keep imagining the real world scale of it. So this is a 1 meter ball. This is like that much. So everything you add to the scene, just think about the scale. Just so the sandstorm comes from, like, let's say there's a like kind of hill here, there's another hill there. So the sandstorm comes from a source that is as big as I don't know, 10 meters. So I make it like 10 meters on Z. You can so when you add, you can press enter and just just do it here, like scale it up or just whatever you want. So I want a kind of a source that is, I don't know, 4 or 5 meters to 10 meters. So this is a fairly large, so this is 10 meters. So from here to that, to the end of our class. So how I know that? Look at the, actually it's a 20 meter. So like here, see 0 to 10, 0 to minus 10. So I rotate it a bit. So just imagine that like all the storm gets thrust out of that. So if you put a camera here, click on the camera. By the way, you can hold Control and click on the camera. Then this will be your camera. And then you click on lock to lock your camera because you want to change the camera. So I don't see my source, so which is safe, I just see the sandstorm. So if I unlock it every time so you work around, so every time you want to like check the result, you go to this cam and say cam 1 and you look at the results. Okay, so this is my camera, this is my sandstorm. Let's get inside. Okay, so you want Pyro, create Pyro, as simple as that. So before, you should have rasterized this or create a volume out of that, like volume rasterization out of that. Send the volume rasterization to the solver. source the solver, you know, put an object, a volume object there. Actually, these are the things that we will do for liquid simulation. I'm saying all of these because I just want to justify and explain why liquid simulation is so complicated, because it still follows the classic or just the older way of methods of workflow, which I hope would be updated and becomes as nice as this Pyro simulation. So here just tab and say Pyro. We just want to configure Pyro, configure maybe a billowy smoke. So you suddenly see that a nice and neat set of nodes are added, and the smoke source, which we will change soon. A node, a Pyro source that creates density, which means like the cloud. Noise, a bit of noise, you need that. Rasterize to turn the noise and Pyro into volumes, and then solving it. So when we play that, so you see that like at the middle it has added a sphere, like a 1 meter sphere, and simulating that. So I change that sphere to you know, my sphere. So you saw that it was very easy. Just press tab and press configure billowy smoke. So it takes time because mine is about 20 meters. So 20 meters means a lot of smoke. Maybe I should make it smaller for now, for a faster simulation, and then you do it the large one at home. So I press escape. Just for now, for the again, like it's very sensitive to the scale. I just want to make that like smaller, like 10 times smaller for now, or I just want to take it closer to the ground. So now when I change it, I should get a quick response back. So when I play it, I should see smoke rising. Okay. This is like 2 meters now, or 4 meters. It's not like, look at here, it's just like 2 meters this way, 2 meters that way. It's about 4 meters, which is much more manageable for the sake of simulation. So it's a bunch of clouds that, so I don't need this sphere anymore. This is just like added by default. This cloud looks boring because in the solving, in the shape, there's no turbulence in it, so you can, and the sandstorm has a lot of turbulence, as you know. I just add a lot of turbulence, and there's no force. I want a force to push these clouds into this direction. What is this direction? Look at that red, says X. So when you double click on your Pyro solver, it's guiding you. It says use a gas microsolver here to apply forces. I do that. So I type gas, and you see all these sorts of like, you know, different forces, like, I don't know, dissipation and turbulence and buoyancy, let's say, for the liquid. So I type gas, oh, sorry, gas wind. Oh, there it is. I need just wind. And I, you know, just plug that wind into what the place it says. So here is X, Y, Z. I want it to be pushed to the X, like, I don't know, wind direction, like 2 to X. but at the same time I just want it to come down and hit the floor, so maybe a little bit down as well. So that's Y. Green is Y, so I say -1 on Y. So let's play this. So it's coming, but it's very still doesn't have that much of turbulence I want. First thing first, before carrying it up, I suggest to see your, so do you see the smoke coming? There's not a good shading or lighting on it, so it's just add a skylight in your lights, and here click on the skylight. You see it much better. It's very organized. I want a lot of turbulence. Again, shape turbulence more. I don't want it to dissipate, or maybe dissipation is like fading away and dying. Okay, so I just lower that down so it doesn't die too early. A bit of disturbance, more disturbance. Plate. Okay, so look at those cool shapes that are popping out. They are very interesting. So it looks sort of like, especially from this angle, like sort of what I want, but it doesn't hit the floor, you know. This is the floor. It must hit. What's wrong? So you see that here, when I hover on top, it says volume for collision. So you can simply press P here just to empty the area. You can simply add a grid as your floor. So this is my floor, and chuck it there. That's it. That's, you get a simulation round. You see that it's hitting the floor, and there's a space here, and actually that space can be adjusted when you get inside. It's simulating, so whatever I'm doing, so it's just like slows things down. So what you see here, that some of the simulation is just faded away, is because of the cache. So there's not enough memory to hold all of that. So that looks like a cool storm, isn't it? And then look at the space between the grid, which is here, and the storm. You can adjust that space, not here, but when you select your Pyro solver and press P, there's a collision side somewhere that you can adjust it there. Collision space or something. Simulation, gravity, or whatever. Oh, by the way, if you want like a higher gravity, it's there. I don't know, it was somewhere. You can find it and you can adjust it. There it is, collisions. So there's a distance between your collision and that can be adjusted here. So you saw that, like, I just put, so what you saw here that has happened with just few nodes used to take much longer, with like all traveling from sub to dub and coming back. So let's say you want to turn these into tiny little dusts, like sands. Just add a pop network here next to it, and so inside pop network, what you get is a pop object, a pop source, a pop solver. All of pop means particle operators. So where the particles coming from? They are coming from. So the first input says like is for the particle shape. When I click on that, so let me go to the first frame. You see that, like when I click on, when I actually it's good to add a, what was that thing that we used to add? Oh, when I hold Alt, let me delete that. Oh, sorry. When you hold Alt and like move things around, you can tidy them up a bit like this. So the object has turned into particles, and so as simple as how many particles, you can say here, well, we'll do it just now. Pop object is the particles, source is sourcing the particles from your source. Here says merge pop operations or particle operations here. So we don't need that one. Actually, it's guiding us. The one that guides us to say that, hey, look at that volume or pyro and move these particles with that pyro is this pop advect. Pop advect. Advection means, guiding through, pop advect by volume. So we have a volume. Pyro simulation is a volumetric simulation. I add it here. And here I press P and say, hey, where is your pyro? Actually, I should add a nice and neat. So I go up, I add a nice and neat null, which means nothing but a guide here, and say that this is out pyro. So there I want to say that my sub-level pyro is this out pyro. Okay. So, and one little thing is that inside the solver, I gonna say that, not the solver, but inside the pop object, I believe, or source, sorry, source, the birth of the particle, I just want to say that do not generate particle. So just so the birth rate, so the constant activation, constantly do not emit particles, just don't do anything. Yet give me like, I don't know, 1,000 for now, 1,000 or 2,000 impulse counts. So just put some points there, and then these points, you don't need to do anything. I have my advection there. So when I start playing, so these particles actually they follow the same behavior. So exactly like we just filled in our pyro simulation with the behavior, so like the particles basically. So these particles just follow the behavior of my pyro. So so if you just compare, actually I'm gonna get into my sandstorm. I'm gonna play it. Or you know guys, always you have to, the reason that things got wrong here was because of caching. It's always good to be a professional and cache things. Actually the first sign of me being fired because of not professional is that I didn't set any project and the project is not saved. Oh wow. So like I should create a new project. in desktop, call it Pyro advection, Pyro particle advection. That's my project folder. Pop is the name of it. So that's my project. Control S. I save the job, which is this one. Pyro particle advection version 1 there. So why I did all of that, because I just wanted to mention that the right way of doing thing is file cache your. So we constantly generate, because you know simulation means thinking about the current situation based on you had it before. So like the cloud moves or the fluid moves because every frame looks at the previous frame. So it's a calculation on the fly. So every time that you play it, the result might be different. So that's why it's important that you cache it on hard drive, and then it turns into data on your hard drive and not calculation or computation on the fly. So sorry, I just changed to mic. So my voice was recorded, but like anyway. So file cache. So where should so you see that like you can say that go to the job, which is the project that we did, and there's a sim folder there. You can say that this is Pyro $$F, which means like frames. So bgo.sc is Houdini standard format for saving files. So you see that one there as well. So there's operation something as well there, but I don't need it. Maybe I hold Control and Shift and click here so to remove that, and I say that okay, maybe 50 frames is enough. Actually, I want to set my project for 50 frames and save the disk. So you see that it starts to do the calculation. Let's have some tea. Okay, the caching is done. So once the caching is done, so you might just start playing and say, oh, where's my cache? It doesn't work, blah, blah. So what you have to do is, I just want to switch to the output. Just want to say that, hey, go and read the cache, read file. So when you read the cache, even when you disconnect here, it's just the magic is here. When you even disconnect, it works. So you see that like it's just there, it works very well. So it means that the caching, it's not loading from calculating the simulation, it loads from data that is like kind of hard written on hard drive. So it's fixed. I should say it's stable on hard drive now. So let me just like reiterate that pop network site. So just say it again. So as simple as adding a pop network here, and this would be, I just call my solvers. This is Pyro solver, but no, I don't know. It was called Pyro solver anyway. But this, I like to name this pop solver Sandstorm solver because it's particle. So the Sandstorm needs to look at the source object. the source object is this sphere that I made. So I add from transform to the first node, and you saw me holding Alt, click in the middle, and then release it and then move it around just to tidy things up. So here inside my pop network, I have a pop object, which is particles. I have a source, and I have a, you can wire multiple forces here. Actually, I could have not deleted this. I could have connected different forces like pop advection. Pop advection by volume. So this could, come here. If you have advection and then turbulence and then this and then that, all of them can be merged. So this pop advection reads that out Pyro, as simple as that. The thing is just in the pop object, no, on the sourcing, say that there's no particle needs to be born by the constant activation. Constant activation means like you're a source, spawn particles, throw it away. But you don't want to do that. You just say, I have my particles, which is like I have 2,000 particles, and they are impulsively gonna follow my Pyro. So that's my plan. So then if I go forward, you see that I have 50 frames of simulation. Now that I jump forward, it's so easy to work with. The reason is I can here say that add a null here, and this is gonna be out particles. So you see that these particles are looking at that file cache of the Pyro solver, and they behave the same. So look at the behavior. It's pretty much the same as this one, very close. So the more particle, actually maybe I add more. Maybe I say 4,000. Let's see what happens. We have to do the simulation again. I think I managed to. Oh, this is an issue with the. Why something has frozen here? What if I changed my? I don't know. There's a viewport issue, which is all right. But okay, if you open and close Houdini, that should work. So I have more particles now, and it looks much closer to the cloud now. How to and about these little things, just as simple as, so these are points. So if you click on here, you've got that amount of points, and you know that, and each one of these points have a velocity. You see that when I turn on this velocity is basically the most important parameter in simulation. It's the speed of every little particle in your system. So here, when I turn that on, I can see the velocity kind of indicator that shows where they are and which direction they are moving. Just if you have a little tiny sand, like a little polygon with I just want to make it the tiniest, simplest polygon, frequency 1 maybe, yes, and add a mountain, and I don't know, maybe, yeah, something like that, and make it infinitely small, very small. It's not that small, I want. Oh, it is. So why? Oh, okay, so the mountain doesn't move. Okay, so I just add just that sphere. It's tiny. It's very tiny. Maybe add a color to it. You know that this color is just a viewport thing. It's not your color. You have to assign material to see properly. And then say copy to points. Copy to points. Say that this is my object and these are my points, and that's my sandstorm. So you see that like there's a sandstorm here. See sand? So maybe I make it like larger. So, oh yeah. I actually, instead of making this larger, I should, yeah, proper sand now. I should go and increase the amount of particles popping out, which is here, and it's inside, no, sorry, source and like impulse count, that's the one. Anyway, so that's a quick overview of Pyro and particles, and that's for now.